right, so then there's HVAC systems in the building. There are various types of HVAC systems in the building. Um, Obviously, you can have anything small from bathroom ventilation, your whole building HVAC system. You're gonna have all different sizes, and not all of them utilize a fan large enough to be part of smoke control, or they use a fan at all. Um, Various supply and return. Your strategies can exist, and you can use some or all of them depending on which part of the system is being incorporated. Um, so it's not typically shown in the test. This is not necessarily the types of systems, not necessarily the material, but Annex G is going to have more information. However, the types of fans being used in that system are important. So the fans are important because the HVAC system and the smoke exhaust system can use different fans to create different mechanical air movements. Your fans can provide both your exhaust and your makeup air, your supply air. Um, Typically, centrifugal fans are preferred. Blade type fans are usually prone to instability or inconsistent flow, especially in windy or other atmospheric conditions where that entering wind is unstable and inconsistent. The centrifugal fans create a much more reliable airflow, and you can anticipate the static pressure and you can be much more confident in that pressure and that airflow you're getting out of it. In this, your fans need to be rated for your expected smoke temperatures. Obviously, you're going to be seeing temperatures that are higher than the average building would experience. You could 1, 2, 300 degrees possibly. The fans must not operate in the motor service factor, and the fans must have 1.5 times the minimum number of belts required to operate. So if your fan is required to have 1 belt, you need to have 2. You're rounding up 2 belts. You need to put 3 belts. There's 1 there for redundancy. The last 2 are from the IBC, but they're common. They're in good design practice. I believe in some of these, some of the references they are repeated. And then finally, for the fans, if you're using fans to drive it out, you must put your discharge located in a way to eliminate that reintroduction of smoke into the building. So dampers are another component here. That's what's going to open or close, allow or not allow that movement into the smoke shafts or across different areas. So a damper is a series of plates that stop the flow of air and smoke inside that ductwork. Obviously, they're used in that system to isolate, direct, control the movement of that smoke down the shaft. There are required ratings and leakage classifications. Those will not necessarily be tested. Again, that's there for IBC rating. The dampers itself must be UL 555 or UKL listed if they're being used as part of a rated assembly. And if they're used as part of the smoke control system, they need to have that third-party verification. So ductwork, like the previous components, ductwork again is part of the HVAC system. And then using the system can be similar. You can share ductwork between those 2 systems. However, of course, the ductwork that for the smoke control must meet higher standards. So it must be continuous. It must be pressure tested to 1.5 times the design pressure, and it must be leak tested to less than 5% of that design flow. And obviously, all the equipment must be able to withstand that expected temperature and pressure of that fire, and it must be tested as part of a third-party special inspection. The ductwork needs to be supported using appropriate supports, and actually does not have to be metal. It can be formed by gypsum or other compliant material as long as it meets those code requirements. However, sometimes those non-standard materials can have trouble meeting a leakage requirement, so careful design by the fire protection engineer or by the HVAC engineer working with fire protection engineer is necessary. So system interfaces and initiating